Okay, dear students, we're going to discuss about stationary waves. Stationary waves are waves formed when two progressive waves which have the same frequency and amplitude travel in opposite direction and which are in the same medium meet. So we have four conditions for stationary waves. Number one, two waves must be progressive waves. This means that they must emit wave continuously. Number two, they must have the same frequency and the amplitude. Number three, they must travel in the same medium. And the last condition, they must be in opposite direction. Okay, dear students, for example, this is one wave which is traveling to this direction. This is traveling to this direction. But also, this is another wave which is traveling to this direction. So when they meet, they are going to form stationary waves. And the point whereby the displacement is zero is known as nodes. But the points where displacement is maximum are known as antinodes. So these are antinodes. These are antinodes. Okay, dear students, let's discuss about fundamental frequency, harmonic, and the overtone. When we are talking about fundamental frequency, this is the lowest frequency that can be produced by a string or pipe. But when we are talking about nth harmonic, this is a note whose frequency is nth times that of fundamental, whereby n must be a whole number. And when we're talking about overtone, this is the highest frequency that can be produced with a fundamental frequency. Okay, dear students, let's discuss about standing waves in string fixed at both the ends. Let us start by fundamental note, which is first harmony. So this is the length of the string. From this point up to this point, this is the length of the string. But will be equal to a half wavelength, because this is half cycle. So a length of a string is equal to a half wavelength, whereby wavelength is equal to 2 lengths of the string. So from velocity is equal to wavelength times frequency, but this is fundamental frequency. So fundamental frequency is equal to velocity over wavelength. But wavelength is equal to 2L. Therefore, fundamental frequency is equal to velocity over 2 times wavelength. Okay, for first overtone, which is second harmonic. So this is the length of the pipe, of the string, but which is equal to wavelength, because this is a complete cycle. Therefore, length of the string is equal to wavelength. But from velocity is equal to wavelength times frequency. Okay? But this is the frequency of the first overtone. So we have to make this frequency of the first overtone the subject of the formula. Therefore, frequency of the first overtone is equal to wavelength over is equal to velocity over wavelength. But wavelength is equal to length of the string. So frequency of the first overturn is equal to velocity over length of the string. From this equation, that's frequency of the first overturn is equal to velocity over length of the string. If I take this equation and multiply by 2 and divide by 2, it does not affect our equation because this is going to cancel with this one. But fundamental frequency is equal to velocity over 2 times length of the string. Therefore, frequency of the first overturn is equal to 2 fundamental frequency. Okay, so let's see about second overturn, which is third harmonic. So this is the length of the string. From this point up to this point is the length of the string. But from this point up to this point is equal to 1.5 wavelengths, because this is a complete cycle from this point, which is wavelengths, plus this is a half, which is equal to 1.5 wavelengths. So length of the string is equal to 1.5 wavelengths. So length of the string is equal to 3/2 wavelengths. We have to make the subject's wavelength. So this is over 1, cross multiplication. So this is 3 wavelengths is equal to 2 times length of the string. Divide by 3, divide by 3. Therefore, wavelength is equal to 2 times length of the string over 3. Okay, from velocity is equal to wavelength times frequency, but this is frequency of the second overturn. So we have to make frequency the subject of the formula, which is equal to frequency of the second overturn is equal to velocity over wavelength. But wavelength is equal to 2 times length of the string over 3. So we have to substitute to the equation. So this is frequency of the second overturn is equal to velocity over 2 times length over 3. So the frequency of the second overturn is equal to 3 times velocity over 2 times length of the string. But fundamental frequency is equal to velocity over 2 times length of the string. Therefore, frequency of the second overturn is equal to 3 times fundamental frequency. Okay, so the frequency of nth harmonic is given by this formula, that frequency of nth harmonic is equal to n times fundamental frequency, whereby n is equal to 1, 2, 3, 4, and so on. But the condition that n must be a whole number. So this is the general formula that we are going to use, and we are going to see some example on how to use it. Thank you.